Hi, geometry scholars. So today we're going to talk about section 3.3. We're also going to do some review problems from 3.2, but for right now, I'm going to present some examples through the book resources, and we're going to talk about proofs with parallel lines. So far we've gotten a bunch of theorems about parallel lines. And now this section is talking about the converses of those theorems. So if you have parallel lines, then your, let's say, alternate interior angles are congruent. The converse then would be if you have alternate interior angles that are congruent, then you get parallel lines. So for each one of these, the first four, we've already talked about the conditional statements, and now we'll show how the converse is also true. And then the last one has to do with the transitive property of parallel lines. So we're going to go through these. Again, these vocabulary words are all in your glossary. We've also gone over them, and they're in the Quizlet in Teams. So let's go through the slides that I want to go through on here since they're already made. You should either have your journal out and or have printed out the 3.3 notes from the class notebook that I supplied for you. So theorem 3.5 below is the converse of the corresponding angles theorem. That was the first one. And so here it is. If two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel, which is we started with 3.1 that if you had parallel lines, then you get corresponding. So now we're doing the opposite. If you have corresponding angles, then you get parallel. That is the theorem. So this is how you're going to use it. And I'm hoping this is playing loud enough. Here we go.
Find the value of x that makes line M parallel to line N. Solution. Lines M and N are parallel when the marked corresponding angles are congruent. Using the corresponding angles converse, you can write the equation, the quantity 3x plus 5 degrees equals 65 degrees. To solve for x, first subtract 5 from each side of the equation. This gives you 3x equals 60. Then divide each side of the equation by 3. This gives you x equals 20. So lines M and N are parallel when x equals 20.
Very straightforward. Okay. We're going to do another one. And no, we're not doing construction. Sorry. 3.6 is about alternate interior angles. So if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. And similarly, we're going to do the other two as well. If two lines are cut by a transversal, so the alternate exterior angles are congruent, then those lines are parallel. And third, the consecutive interiors angle converse. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, remember they add up to 180, then the lines are parallel. So each one of these proofs, as you can see, example 2 is on page 140 in your book. The proof for this one's on page 142, example 11, and this one is example 12, page 142 also. We'll go over some of those in class, but for this video, I like to keep them short, and we will continue to show an example problem. So if I want to prove one of these, this is how I would go about it.
Prove that if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Solution. First, draw a diagram with two lines that are cut by a transversal. Label a pair of congruent alternate interior angles as angle 4 and angle 5. Now, to show that the lines are parallel, you must first show that a pair of corresponding angles are congruent and then use the corresponding angles converse. Notice that one angle is a vertical angle with angle 4 and a corresponding angle with angle 5. Label it angle 1. Now you are given that angle 4 is congruent to angle 5. You need to prove that line G is parallel to line H. Write a 2-column proof. First, write the given information. You are given that angle 4 is congruent to angle 5. Next, angle 1 and angle 4 are vertical angles. So, by the vertical angles congruence theorem, angle 1 is congruent to angle 4. Then, by the transitive property of congruence, angle 1 is congruent to angle 5. Now, angle 1 and angle 5 are corresponding angles, and you have shown that they are congruent. So, by the corresponding angles converse, line G is parallel to line H.
Hopefully you can follow all of those. We've used them many times by now, and we will continue to use them more. Here's another example. And this one's a little different. So watch the colors and also watch the parallel line. The markings are only on R and S. You're showing that you're gonna show that P and Q are parallel. So there's only certain things you can assume.
In the diagram, line R is parallel to line S, and angle 1 is congruent to angle 3. Prove line P is parallel to line Q. Solution. Look at the diagram to make a plan. The diagram suggests that you look at angles 1, 2, and 3. Also, you may find it helpful to focus on one pair of lines and one transversal at a time. Plan for proof. A. Look at angle 1 and angle 2. They are corresponding angles. So, angle 1 is congruent to angle 2 because line R is parallel to line S. B. Look at angle 2 and angle 3. They are alternate interior angles. So, if angle 2 is congruent to angle 3, then line P is parallel to line Q. Plan for action. A. It is given that line R is parallel to line S. So by the corresponding angles theorem, angle 1 is congruent to angle 2. B. It is also given that angle 1 is congruent to angle 3. Then angle 2 is congruent to angle 3 by the transitive property of congruence. So by the alternate interior angles converse, line P is parallel to line Q.
So hopefully you're now seeing the plan starts before you ever write anything down. And then this is more of a paragraph proof. It's not a 2-column proof because there's no column there, as you can see. But you could write it as a flow chart too. We're going to stick with the 2-column proofs for now. And then we have one more theorem to go over. And we'll do this part in class together so I can answer questions and or see your reactions for monitoring progress. There's one more proof, and this has to do with transitive property of parallel lines. So if you know that 2 lines are parallel to the same line, then they must be parallel to each other. And this makes sense. In algebra, they all had the same slope, right? That's how we could determine if 2 lines were parallel. So if you have 3 lines with the same slope, then they're all parallel to each other. Anyway, if you want to see the proof, you can look on example 39, page 144, and or example 48 on page 162. And we're going to start some problems. First, we're going to just make sure that you understand a word problem, and then we'll keep going.
The flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Solution. You can name the stripes from top to bottom as S sub 1, S sub 2, S sub 3, and so on through S sub 13. Each stripe is parallel to the one immediately below it. So S sub 1 is parallel to S sub 2, S sub 2 is parallel to S sub 3, and so on. Then S sub 1 is parallel to S sub 3 by the transitive property of parallel lines. Similarly, because S sub 3 is parallel to S sub 4, it follows that S sub 1 is parallel to S sub 4,
etc.
By continuing this reasoning, S sub 1 is parallel to S sub
Sub
13. So the top stripe is parallel to the bottom stripe.
It's kind of a simple example, but that's how they work. So on the monitoring progress, again, we're going to be doing that in class together because I want to see, after you do this, we'll be doing some problems in the student journal. Keep that handy, as well as, like I said, you can find those class notes, the Cornell notes in the Avid style in the class notebook. And I believe we're ready to start. So for 3.3, we're probably going to be doing the assignment in Big Ideas, and I'll post it, so just look in the general feed. And we're stopping.